class, Mr. Watlington, and welcome to week 7. Yes, we have made it to week 7. Where did the time go? All right, let's take a look at what we're going to do for week 7 as we get into the agenda. IDSs, IPSs, intrusion detection systems, intrusion prevention systems. We're going to talk about some logging. I'm not going to get deep into email, but I do have a separate video that's attached on DNS and DNS processes. This week we're reading chapter 19 through 21. Yes, the last 3 chapters of the book. We made it through the entire ebook. And as always, we got the threaded discussions and your journal article review. So let's get into our week 7 lecture. IDSs, IPSs, intrusion detection systems, intrusion prevention systems. So what are these? Like I say, IDSs and IPSs, basically what they do, they monitor the traffic, your network traffic. They look for any type of malicious behavior. There is a fundamental difference between an IPS and IDS. Intrusion detection is just that. It will just detect activities, whereas an IPS, intrusion prevention, will actually, will actually stop that packet from getting to its destination. They both have their advantages and disadvantages. So, and when we think about these type of technologies, they work on something they are called signatures. And the signatures are what is used to detect, your network traffic. And based on how you tune an IDS or an IPS, it will look for certain types of things that are anomalies based on some type of a signature. And what is it? Like I said, it's just a set of rules that's used to detect malicious activity. When we think about signatures, no different than we do with antivirus, where signatures have to be updated, where you always get these antivirus updates, right? Well, IDS and IPS is the same thing. You have to get signature updates. Now, when we think about the types of signatures, 3 basic types. Like I said, there are more, but these are the 3 basic types of signatures that what will trigger that signature. It could be pattern-based, and what that is, it is matching patterns. Basically, you've got a predefined set of rules, and this is taking each packet. Now we're operating really at the packet layer, layer 3 of your OSI model, where it's looking at your IP packets and it's looking for an anomalous activity based on those packets and what to do with those packets as it's going between your router and your switches. So there are pros and cons to each of these, right? And I'm just glazing right across the top of that. These, like I say, the pattern matching, they're easy to configure. You don't get quite as many false positives because here again, you're matching against a known pattern. Now, here's the con. It's the big con. They do not detect unknown signatures. And that is a huge con for many things, even your antivirus. When you have signature matching antivirus like Symantec or Norton or any of these, they have to know that an anomaly exists. Because if the companies who build these software packages don't know that the malicious code exists, they don't know what to write the signature against. So why is that such a bad thing? Well, it does nothing for 0-day attacks. And what a 0-day attack, if you don't remember, all that really is, many times when companies, Microsoft or whomever it may be, pushes a new update or a new patch, there are vulnerabilities even in the new patch that it causes that at day 0, no one knows it exists, not even the makers of the signatures for your antivirus, or in this case, for your IDSs and IPSs. So that is a huge problem because there's nothing protecting or defending that. So like I say, and typically, pattern-based, they're relatively inexpensive, with in relationship to some of the others. Then you have the anomaly-based signature. Anomaly-based signature, again, based on what it does, it looks at traffic patterns over time, and it starts to determine what is outside of the baseline, outside of the normal. It sees normal traffic, then if it sees a packet that's outside of what is looked at as the norm, then it's going to trigger on that. So unlike the pattern type, the anomaly baseline do have the ability to, not great, but it does have the ability to detect 0-day attacks because it is looking at normal traffic and baselining that, and anything, like kind of like the upper limit, lower limits, anything outside of that norm that it has established, it will trigger. And then we have what we call stateful protocols or stateful protocol analysis. This is looking at the condition or the state of a particular protocol, whether it's TCP or UDP, or you can even drill deeper into protocols. Whether it's SSH or whatever those protocols, ever how you define it, that protocol to look. Now, the thing with these, they can perform deep packet inspection. And what a deep packet inspection, I'm going to probably take you back to your earlier classes here. When you look at a TCP packet, right, it has headers, it has footers, and then your payload is inside of that. And if you remember that thing about encapsulation, you got your different layers with different protocols. You have TCP, then IP is encapsulated inside of that. And then you have whatever layer 3 protocol is encapsulated inside of that. So some of these higher level, these other signatures cannot look deeply into that packet. It can look at the header address, and things of that nature. Deep packet inspection, that means that now it's actually able to, if the system is tuned that way, to actually look inside of a packet and see if there is something going on, some type of, it could be antivirus or something like that, some type of payload that actually may be in the packet. Now, think about that for a second. It sounds great. However, here is the issue we run into with deep packet inspection. It can slow down the performance of your network. If you think about now, if you have an external piece of software that's looking inside of every packet, how much that's going to slow, how much latency that's going to add to your networking and to your processing. So there's trade-offs no matter which way we go. And typically these stateful protocol analysis type signatures are a little more expensive. And the problem that you also run into is that all protocols aren't created equal. All protocol standards, whether we're talking ITEF or different models, OSI model or the IEEE, they all have standards for protocols. And sometimes these standards don't match up. So you may have your system tuned to look for one thing when the protocol is actually doing something else. So cost, performance, latency, all these things are things to consider when looking at how to set up your IDS and your IPS system. Okay, let's dig a little deeper into IDS, intrusion detection systems. And actually what they are, implemented to passively monitor the traffic on your network. What I mean by that, it is not in line with your actual data. Okay, like I said, an IP-enabled devices, it basically copies the traffic. So I'll look at this sensor right here. There's in this IDS, there's 2 ports on that device, and one port is in what we call promiscuous mode. No, that's not anything that's under the table behind closed doors. No, promiscuous. There's 2 modes you can set up. You can set a port. Promiscuous means that it is going to mirror or look at all the traffic right there. That port set to promiscuous. So everything that's going through this switch is going to also be mirrored onto that IDS sensor. And then the IDS console connects there, and that's how we set that IDS up. So as you see, it's able to monitor traffic offline. So it's sitting over here. Traffic is coming in from, let's say, the internet, from the cloud, through the router, hits the switch, goes to the laptop. This device set in promiscuous mode, so it's mirroring. It does port mirroring, and it's going to send all the packets here so that it can actually analyze those packets based on which type of signature you're running. Like I say, that's why we call it a passive device. It only requires a promiscuous interface off of that switch right there. It does not slow down your network traffic, okay? Because traffic on the rest of the ports are still going as they would normally go. So what happens then? All right. So let's say we get a packet. Boom. Here's a malicious packet. Makes it through the router, hits this switch, and what does it do? It sends it over to this IDS. Yes, and the IDS is examining that packet and says, hey, that's malicious. And then what happens? Pretty much, other than alerting the event manager, then that's about all that's going to happen. You're going to get an alert. That alert could be an email to your IT guys. It could be, or an email to your cybersecurity guy, or something pops up on the screen if you're monitoring this in a SOC, whatever it may be. So you're just going to get an alert. However, guess what? That malicious packet is still going to make it down here to the laptop or to the user. So nothing happened other than the fact we monitored that, yeah, there was some malicious activity. Alert went off, but the payload still made it. Now, in an intrusion prevention system, things work a little bit differently, okay? And an IPS, okay, it still has the same technology as an IDS to be able to detect attack. However, it's also capable of addressing that threat, okay? So it's more in line. Instead of being in the promiscuous mode, now we have our IPS sensor in line with the traffic. So same scenario, right? Same scenario. Wow, we have some type of malicious packet comes in. This IPS senses it, goes, let me send this over to the event manager. Event manager says, hey, that is a malicious packet. But what happened to that packet then? IPS pushes it into the bit bucket over there. Okay, it pushes it into the trash can. So that packet never makes it down here to laptop 2. And if you look at my slides closely, you see it says butt bucket. No, that should be bit bucket. Little fat fingering going on here. Fat fingering. So yeah, so that's how an IPS works differently than an IDS. So it actually will take some action and push that bad packet out. Now, let's think about this. So if you have a sensor, like this IPS sensor, in line, guess what's happening? Every packet is going to go through here, and every packet is going to get inspected. And so now you can really slow down the performance of your network. Now, here's the thing that has to do with really kind of get to the bottom line when we talk about implementing a monitoring strategy. Some factors to consider. It sounds great, guys. It does. Like, yeah, man, we're gonna implement an IDS and IPS. We're gonna see every packet, and we're gonna do this. But I tell you, real world, there are some things that you really want to think about when you're gonna implement some type of monitoring strategy. All right. First of all, you got to have some type of management method. What is going to be your philosophy? Is it going to be an IDS? Is it going to be an IPS? Are you going to try to monitor the entire network, or maybe just some segments of the network, some critical segments? Because if you think about your whole network and you're trying to monitor every packet or every protocol at every interface, you know, the overhead associated with that is going to be, you know, tremendous. So you really have to come up with a management strategy that we're just going to, you know, manage packets coming into through this VLAN, or where critical VLANs are, things of that nature. Second thing, event correlation. Okay. So yeah, so I've got these sensors all over the place, and it is popping events left and right. What are you going to do with all that data? Okay. You got to have some way of correlating those events to make it meaningful. You know, otherwise, all you have is a lot of data and nothing to do with it. No way to make any sense of it. So you have to have a way, some type of tool, some type of asset to be able to correlate these events with other events. You know, there's tools out there that you would typically see in a security operations center. You know, like Bro or Security Onion, that can help with event correlation with monitoring. Incident response. Okay, so you've got these events, you've correlated them. Now what? How do you manage to, okay, once you say, yes, something happens, then what? You have to have some way of managing incident response. You know, what do you do? Do I shut off the network? Do I turn off this VLAN? Do I report this, you know, elevate this up? Is this a possible insider threat? Is it not? Do my security control assessor need to get involved? Or my AO, my information system owner? How far up the chain does this go? All of these things need to be thought through. And how do I handle this, especially when we're talking insider threat, where now it can become a legal situation. You may have to get forensics involved, a lot of steps. And here again, all of these things they point back to your management method. And staffing. Yes, this is a huge one. Because if you're trying to do this correctly, this can take on a life all its own. It can become its own worst enemy. Now I've got to have a separate staff, one, maybe two people that are monitoring my events dashboard, doing this correlation, knowing how to push these events up, constantly tuning the system. Because here's what I mean by that, okay? You have to have policies in place of how we're gonna to what level are we gonna look at packets. If I try to look at everything, I'm pretty much gonna shut down my network. If I'm not looking at enough, then things are getting through and I'm paying a lot of money for systems that is pretty much useless. And what happens the first time that your CIO or the CEO is expecting this email to come through and you've got this thing tuned so tight, and boom, those packets get dropped on the floor in the butt/bit bucket. Yeah. Well, guess what? They're going to be talking to the excuse me, the CISO, going, hey, what the heck are you guys doing? So it's a fine balance when we talk about implementing a monitoring strategy. A lot of things go into that. All right, let's switch gears a little bit. Let's talk about system logging and security event and incident management, SIMs. A lot of different tools out there for SIMs. Log collector, you've got Splunk. There's just a myriad of different tools that you can buy, different type of SIM tools. However, functionally, they all work in a similar, not the same, similar fashion. Let's take a look at that. So when we talk about events, I think it's helpful to kind of step back and understand how audit events are generated. And this is from using a Windows machine, okay? It all happens right here, starts right here in your operating system. Now, let's talk about operating systems for just a second. At the heart of every operating system, whether it's Windows, whether it's Linux, whether it's Mac, Solaris, an embedded system, whatever it may be, you have a kernel. And that kernel really is what manages everything that goes on. If you remember back years ago, we had this thing in Windows called MS-DOS, Microsoft Disk Operating System. That was the kernel that controlled how information was written to the disk and how information was brought back from the disk. All right, now a layer around that is what we call the API or device driver layer. Like I said, these are your interfaces that allow these upper layers to be able to talk to the kernel. Then around that, or laying right here next to that, is what we call our operating system applications. Please don't get those confused with user applications. We're not talking about Adobe, Windows, all these user applications. These are operating system applications like File Manager or your control panel or the shell, the command line interface. These are the type of application level interfaces or applications, apps that we're talking about. Because now I need to be able so basically when you buy Microsoft Windows 10, this is what you get: the blue, the orange, and the yellow layers. That makes up a Microsoft Office, a Microsoft operating system. Now you may say, well, how does that compare to something like Linux, like Red Hat? Well, what makes that different is what's called a distribution. Now with a Linux system, it's all built around an open source kernel. And then that kernel is available to anybody. Windows, you can't get that kernel. Even on a Mac, even though a Mac is a Linux or Unix-based operating system, you still cannot break it down to the kernel. But if you looking at Ubuntu or Fedora, or you pick any of those distributions from Linux, you can get that kernel by itself. You can add your own applications to it, and the shell, whether it's a bash shell or Bourne shell, whatever it may be, and now you can build at your own operating system. This is why, like auto industry and industrial complexes, they love Linux. Why? Because I can get this kernel, I can add what I want. Think about your vehicle. Most of us probably have relatively new vehicles with some type of integrated, stereo, dashboard, and all that stuff in there. Well, behind that is running a Linux kernel. But instead of having to try to buy a Windows operating system with all this stuff, the auto manufacturer is able to take this Linux kernel, add on the applications, just the ones they need, like turn on windshield wiper, turn on off radio, turn on camera, backup camera when you go to reverse. Those are all scripts or applications that they add to this Linux kernel. Keeps it very lightweight, very lightweight. So now they don't have to have a lot of memory. Could you imagine trying to install Windows 10 in your car? How much memory you're going to have, patching, keeping up with just the whole 9 yards. That's why we love Linux. Yes, that's why. So this is your operating system. Then on top of that, that is where your user applications reside. You know, your office suites, Windows, if you're a gamer, you know, whatever games you may want to play. That's where all that stuff resides. Now, underneath that operating system, now we have hardware, okay? So let's look at our hardware. We have hard drives. You could have a hard disk drive. It could be an SSD, a solid state drive. We've got our main memory, like RAM. We have cache, layer 1, layer 2 cache. Actually, we've got layer 3 cache now. And then we have our CPU. Now, what controls all of these activities? Yes, that kernel. So if we want to do anything on our computer, the kernel is what says, hey, you know, based on what commands it's given from an application. Let's say you want to open up and edit a Word document. Well, Microsoft is you open up Word, and Word says via the operating system, via a command through the shell to that kernel, says, hey, go to the hard drive, look at this location, and pull up this file. Now, files only mean something to us humans. To this computer, it's still ones and zeros. So it says go to this location, you know, in ones and zeros, in hex and binary. All right, and it pulls all those ones and zeros from different places on the drive where it's written, and it pulls all that up. Some of it in a whole in a page file. It depends on how much RAM you have, but the rest of it's going to push into our main memory, our RAM. So now, as well, it's going to also push some instructions into our cache. So I got instructions, and I've got this document, so it knows what to do with it now. So now it knows how to fetch, okay, and how to read, and how to save things back. So now it goes, it's clocked, you know, based on the clock speed of that operating system, to the cache, to the CPU, and the CPU actually make things happen. So operating system that's sitting on top of hardware, that is what makes up basically your computing system. So you say, well, what about these events? Weren't we talking about audit events? Yes, we were. Or log events? Well, every time one of these actions happen, whether it goes to the hard drive or you log on, you know, boom, anything that happens like that in a Windows environment, there's a audit event code or an event ID that's assigned to each one of those functions. So let's say you log in. Well, it's going, when you log in successfully, it's going to create a code 6424. I'm sorry, 4624. Getting dyslexic here again. 4624. Okay. Now let's say if this login was unsuccessful, it's still going to generate a code. I think it's a 4625. Now when you log off, it's going to generate a 4647. So all of those codes, all those IDs are generated by everything that's going on within this operating system. It's generating and logging these codes in a file and call your event viewer file. Now there's different types of logs. You got system logs. You know, system logs, like I say again, it captures certain things about the system. You have application logs. This log captures things. If you open an application, you close an application, you do something within that app, it's all captured. The one that we work with from a security perspective the most is the security event log. And like I say, this captures any security relevant event. And it can capture that in a file called event viewer. Now you can actually open up event viewer and you can see, you can see everything, all of this activity, and you can do a manual audit on this operating system yourself if you like. When I first started auditing, that's how we did it. It was all manual. Okay, right. You would go to each machine, pull up the audit event log, and you would start annotating what activity. Someone logged in here. They logged out here. Or someone logged in, they didn't log out. and which was very manual. Well, that's where SIMS, security event and incident monitoring came about. So that says, so let's take this event viewer. I know this is probably pretty hard to see, kind of small here, but yeah, this is what a typical event viewer looks like. And here's a list of all the events that have happened over a given period of time. And you have a look at what's inside of that record. So as you click on each one of these, down here it's going to show you what the event ID is, what time it happened, all of those things. And like I say, here's a nice exploded view of that. So you can see all the things that happened in that event, as well as what the event code was. So that is really the basis of what we use now to start to develop an audit trail. But let's say I have 100 machines. Wow, think about the time it takes to do that with 100 machines. That's why we take tools like Splunk. Now what Splunk does, like I said, here's a single event viewer, but let's say we had multiple. We got a whole bunch of event viewers, a whole bunch of hosts, of assets, and they're all generating event viewers. Well, here's what we can do. All right, we can put a thing called a forwarder, a Splunk forwarder on each of these machines, and tell that forwarder that I want you to capture everything that's happening in this event viewer for the security logs. You can have it capture whatever you want, but I'm just going to tell it, I just want you to capture what's in the security logs, and I want you to send that to something that's called an indexer. Basically, think of an indexer as a big database. That's all this is. It's going to take all this stuff and it's going to just drop it in and format it in a way, in a database structure. So once you do that, now you're able to use what we call a query language. For Splunk specifically, it's called SQL, Splunk query language, all right? The Splunk query language now is able to go query this index or this database based on what type of query that a script. You can write a script just like SQL or any other database. You can write a script, say, go look for this, 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 and this. That is really what your SIMs, this is pretty much what they do. You have some type of device that's forwarding events, excuse me, into a database, and then you have some type of query function that you can query that database. So what does that look like, day to day? Looks something like this. This is just a screen capture of a Splunk dashboard where I had wrote a query. I wanted to look up logins, logouts, after hour logons. After I just wrote a script says look for logons between 7 p.m. to 5 a.m. So it's just going to now search just for those, because I want to be able to see people who may be on the network after hours, who's using the system, so that kind of gives me some indicators from a threat hunting perspective is, hey, why is Chuck and Charlie in here at 11 o'clock logging in? I'm seeing activity that I probably shouldn't see if we're not a 24/7 work center. So yeah, so like I say, so if you see, this shows that I got 1,414 logins, because that's what that query, the query I built, did that for me. So when we think about this, let's take a little closer look at these queries. This gives you an idea of what the query, a basic, very, very basic query looked like to do just what I did. So I have to tell it what index, okay? Now when you set up index, just like setting up databases, you could have multiple indexes, just like you can have multiple databases. And then you could have a search head that can look at all the indexes or pick an index. Good, there's pros and cons to doing that. The pros is now I've got like things together. I may just want my Linux boxes in an indexer, Windows boxes in an indexer. If you may have some other or switches, layer 2, layer 3 devices in their own Cisco index. So now it makes my operations much quicker, because if I know what I'm looking for, I can just write a script that says, hey, just go look at this one indexer. Like for here, indexer equals win events. That says, don't worry about the Linux, don't worry about Cisco, just go look for Windows. So it decreases search time. However, if I don't know what I'm looking for and I need to query across multiple, now I've got to write a script that says indexer equals, that's how I can put asterisk in there, says meaning wildcard, look at all the indexes. Or I got to put an indexer for look at Windows, Win events, and Linux events. So you see there's trade-offs either way. All right, so in this particular example, I'm just using one indexer. Indexer equals win events, and I say event code equals 4624. So what is that going to do? When I write that, well, what it's going to do is pull up in Windows how many logons, and as you see, it pulled up the results, 1,404 logons. So it didn't look at all the events, it just looked at 4624. And what is that telling me? So over here on the side, now this gives me a lot of information about that event. It tells me how many hosts, the source, what domain this machine was on, just a lot of things, the date, the time, the event code, all the information is on that side. So I'm starting to get more and more information about this particular event. And if I now, this is each, and actually there was 1,404. This is just one of those 1,404 events. Now let's say I click on this, I can actually drill down and get more information, more details. I can click on the account name and I can get more information. So when I clicked here, actually look at what it showed me. Account names. Wow, boom, there I am. So these are the different accounts that have, that had logged on with this event. I'm this guy named Larry Wallington. Don't trust him. So he may be that malicious player that I want to watch his activity. So now I want to drill down more into that one. All right, so what do? Easiest way is to modify my script. Yes, so now everything else is the same. I got my index equals win events. I'm still looking at 4624, meaning logons, but now I've narrowed it down even further. I want to see everything with an account name of Larry Watlington, that guy you just can't trust on your network. So you see now I'm letting my tool do the work for me. By writing these scripts, it is now really starting to neck down, skinny down my search. So when I do that, it gives me just events for Larry Watlington. Now if I can scroll down and see through all of these, or I can click on one of those, boom, and you see it expands. And now here's information, a lot more information of what's going on. And it says what here, an account was successfully logged into. And you see there's a lot of information down here in this message. So that is really how you can drill down and start actually putting together an audit trail based on the logs. So just getting logs is one thing. Having pretty dashboards is another thing. But really now start putting together audit trails, seeing activity, who logged in when, and what they did while they were on the network. That is really the next part of that. But you still see, that can be very difficult to read, especially if you have a lot of events. So one of the other features that most of your SIEMs, Splunk does have, where you can build tables and you can export. So now if you look at kind of what I did here, I don't know how familiar you may or may not be with scripting language, if you've ever done anything, with Perl or even with Linux. There are some standard semantics, syntax that you use. So up here, you see everything else is pretty much the same. I put a pipe and I said table. And that's a command. That is a scripting command for Splunk. That way it knows it's a table. Now in that table, I wanted to show the time. I wanted to show the account name. I wanted to show login time, and I also wanted to show the network address where this happened. So those are the columns that's going to be in my table. So now I've taken this unstructured data and I've now put it into a structured format, in a tabular format. I can download this, export it as a CVS file, right? And then once I do that, I can open it up in Excel. And once you get into Excel, now I can do other types of manipulations and everything else, making charts and graphs. And you can also make those within the tool itself. But that is how we're able to take logs, log events from one machine all the way up to multiple, to hundreds of machines, thousands really, and start putting together some type of audit trail and correlation and correlating those things together. All right. And so, like I said, once I exported it to Excel, kind of looks like this. easier for some people to work with. Because here's my thing, you know, and really this is what I do. I do this on a day-to-day basis. When I have security analysts or our ISOs, security officers, I want those guys to be experts in auditing and threat hunting and not have to be experts in Splunk or the tool. So we do a lot of work to fine tune our dashboards so that now the individuals who are doing this day to day, they can start looking at activity as opposed to having to sit and remember and try to write, you know, Splunk scripts on, oh God, how do I do this? And trying to pull up notepads and things like that. So that's why we try to put things in a format that's easily digestible, where now I can start making really actionable or giving information to leadership who can that's able to make actionable decisions from this information. So we're taking raw data, changing it to information, and from there we want to be able to put it in a format where, or decision quality format, so that a decision maker can say, hey, yeah, we've got some anomalous activity, could be insider threat, so that now we can take some type of action. All right, guys, like I say, I know it's a lot of stuff kind of went through the day. Hopefully it helped you out a lot with respect to IDSs, IPSs, logs, SIM tools. Like I said, I use Splunk as an example here, but most of your tools going to work in a similar, not the same, in a similar fashion. I think this is my last video for this class in week 8. Like I say, that is just your project that you're going to finish up. I tell you, it's been a great class. Just as we wrap this up, if you got questions, again, always reach out and give me a shout out. All right, appreciate it. Have a great week 7.